let's talk a little bit about the domain and range of absolute value functions. First, let's talk about our vocabulary. Our domain is the set of x values in a relation. Range is the set of y values in a relation. These are the same concepts we discussed in Algebra 1. The vertex of an absolute value function is the lowest or highest part of the graph. It's the point of the v. Our domain values are listed on the x-axis, so the domain of an absolute value function is determined by looking left to right on the graph. Our range values are listed on the y-axis, so the range of an absolute value function is determined by looking bottom to top on the graph. For our absolute value domain and range, our domain is pretty easy. If we look to the left, it keeps going. If we look to the right, it keeps going. So it is always all real numbers. For the range, we look at the vertex. And then from the vertex, it either goes up or it goes down, meaning that it will be greater than or equal to, or less than or equal to, the y value of the vertex. In talking about our domain and range, we also need to talk about two types of notation that we use. Set builder notation. This is what we've seen the most often. It uses brackets and includes equal signs, inequality signs, and so on to describe which set of values the elements lie. Our interval notation uses closed brackets or squared off brackets for included values and open or closed parentheses for excluded values to describe intervals or sections that contain those elements. So let's look at this example here. We're going to determine the domain and the range of the following absolute value function. Our domain and range. Let's look at domain first in set builder notation. This is probably what you're most used to. Our domain is all real numbers, so we write that in our brackets, x such that x is included in all real numbers. That funny looking R is the set of all real numbers, and you can just write that as an R when you write that down. Now, for our interval notation, that means x could be anything from negative infinity to positive infinity, and we never use the squared off brackets for infinity or negative infinity because we can't really include those numbers. It's not an absolute finite number. It keeps going forever. So we always use parentheses when we're talking about infinity or negative infinity. So we would write that in parentheses, negative infinity, comma, infinity. For our range, we're going to look at the vertex, which here is at -4, 8. So our y value here is at 8. So I'm going to put, for my set builder notation, I'm going to put y, and I'm going to leave a space for 8, and then 8. So then I'm going to put in my symbol. So from the vertex, I look, and this one goes down. So y, it becomes lower than 8, or less than or equal to 8. So I can fill in that symbol, which means y can be anything from negative infinity up to positive 8. So I would write that as open parentheses, negative infinity, comma, 8, and it can include 8, so I would use the squared off bracket for that. So our interval notation, open parentheses, negative infinity, comma, 8, close bracket. So let's try a couple. Here it says the graph of y equals the absolute value of x minus 3 minus 4 is given. Express the domain of the function with interval notation. So even if I forget that our domain is all real numbers, I can look to the left and look to the right. Now, one thing I also do is I typically try to highlight or underline the important things here. Domain is important. That tells us what we're looking for. Interval notation is important. That tells us how we need to give our answer. So our domain, I look to the left and I look to the right. And both ways, it can keep on going forever. So even if I forget that domain for an absolute value is all real numbers, I can look left and right and see it keeps on continuing. So interval notation means I would write the lowest value and the highest value in either parentheses or closed brackets. Now, it can keep on going forever in both directions, so it is negative infinity to positive infinity, and we would use open or the parentheses because we don't have a specific number that is equal to infinity or negative infinity. So our domain we would write as parentheses negative infinity to infinity. Number 2 says the graph of y equals the absolute value of x plus 1 is given. Express the range of the function. So I'm going to underline range with interval notation. So I'm going to underline interval notation. Range tells me I'm going to look for the vertex first, and that is at 0, 1. So I know that my range is going to have that number in it, that y value. So I look, and from that vertex it goes up. Y gets bigger. So the range is going to start at 1, and it includes 1, so I have the squared off bracket here. 1, comma, infinity, because it can keep on going forever, and I use closed parentheses to demonstrate that. Let's try some with set builder notation. Number 3 gives us a graph, and it asks us to express the domain with set builder notation. And I underline domain and set builder notation because that tells me what I'm looking for and how I'm going to answer that question. So domain, again, even if I forget, it is left to right. And in both directions, it keeps on going, which means x can be any number in the real number system. So I would write it just like this in our squiggly brackets, x, and then I do my bar, x, and it looks like kind of a funky looking e, but it means it's included in the set of, and then we have r for all real numbers. Number 4 gives us another graph, and it asks us for the range, and I'm going to underline that, of the function with set builder notation. So I'm going to underline that as well. So that tells me the format of my answer. So range, that's y, that's up and down. So I'm going to start at my vertex, which here is at 2, negative 2, and my y value is negative 2. So I know that I'm going to have negative 2 in my answer, and from there the graph goes up. So y is going to be greater than or equal to negative 2. So let's go back through what we've done today and make a quick summary of our notes. Our domain of an absolute value function is always all real numbers. It's going to keep going to the left, and it's going to keep going to the right. The range of an absolute value function is going to be either greater than or equal to, or less than or equal to, the y value of the vertex.